In this tutorial, we are going to talk about customizing the snap and socket feature interactions in SimLab Composer through the training builder. What we have in the scene is a bearing puller and a shaft assembly, and using sockets, we are going to simulate the removal of the bearing, using the bearing puller tool. The first thing to do is to add sockets to both objects, so select the bearing puller, and from the Interactions menu select Snap and Socket. Leave the settings to their default values and disable auto socket placement, and make sure that the Make Object Grabbable option is toggled on, and click on Add Socket. Now we need to align the socket's red arrow with the circular base of the puller, so with the socket selected, go to the Move menu, and select Align. Switch the selection type to Pick Edge Loop, and click on the edge loop at the base of the red arrow, then select the color that represents the red arrow's square loop, which in this case is the green loop. Switch the selection type to Center of Curvature, then select the base of the puller, then click Apply. If the socket was aligned with the red arrow pointing inwards, you can click Flip from the Align Objects window. Now it's time to add a socket for the shaft assembly. Select the shaft assembly, and from the Interactions menu select Snap and Socket. With the settings remaining the same, click on Add Socket. Feel free to move the socket to ensure that the red arrow's base is visible since we need it for alignment. From the Move menu, select Align. Switch the selection type to Edge Loop and select the red base as point 1. Select the center of curvature and select the end of the shaft as point 2, then click Apply. Flip the arrow if needed. Now that we have both sockets set up, let's run the VR experience to ensure that everything is working properly. As you can see, once the puller gets in close proximity of the shaft, a ghost of the puller appears, indicating that the puller is ready to snap, and once the user releases the puller, it snaps in place. Go back to SimLab Composer. Before we set up the training builder, go to the Interactions menu and then Snap and Socket, and from the Settings tab, reduce the search distance to around 15 centimeters. The search distance is the distance between sockets that would indicate that the sockets are ready to snap, and if the search distance was too high, sockets would be ready to snap while being too far apart. The plan in the training builder is to set an event where when the puller approaches the shaft and is ready to snap, the claws would open, and once the user releases the puller and it snaps in position, the claws would tighten and then retracts back, removing the bearing. Go to the Dynamic Training Builder. Right-click to access the context menu, and from Events, go to Snapping, then select Ready to Snap. Select the bearing puller assembly from the object tree and attach it to the event. Add a play sequence response and attach the open claws animation sequence to it, then connect it to the event. This would open the claws once the puller gets close to the shaft. Right-click and select Events again, then Snapping, and select Snapped, then attach the puller to the event. Now once the puller snaps in place, we want the claws to tighten, so select the Claws Tighten sequence and add a play animation sequence response and attach the sequence to it, then connect the sequence to the event. Once the sequence ends, we want the pulling animation to start, so add a sequence ended event and attach the Tighten Claw sequence to it, and add another play sequence response and attach the pull animation to it. Keep in mind that we want the puller to remove the bearing while moving, and to do that, we are simply going to change the bearing's parent from being the shaft assembly to be a moving component in the bearing puller. The yoke would do the job since it moves in the same direction as the bearing. In the training builder, right-click, then go to Responses, then Scene Node, Hierarchy, and then Set Parent. Attach the front bearing assembly as the scene node, and select the yoke and attach it as the parent node. Then make sure you attach it to the sequence ended event directly and before the play animation sequence response of the pull animation. An additional thing that we can do is to make the bearing grabbable once the pulling animation is over. Add another sequence ended event and attach the pull animation to it, then add a set grabbable state response and attach the front bearing to it, then connect it to the event. To recap, once the bearing puller is ready to snap, the claws would open up, and once the puller snaps into place, the claws would tighten, and once the claws tightening animation ends, the bearing would become a part of the puller and the pulling animation would begin, and once the pulling animation ends, the bearing would become grabbable. Run the VR experience to test it. As you can see, once the puller gets within the search distance and is ready to snap, the claws open up, and once the puller is released, it snaps in position, resulting in the claws to tighten and for the claws to retract along with the bearing. Since the bearing is now a part of the puller, once we remove the puller, the bearing would be removed along with it, and the bearing itself can be removed since we set it to be grabbable.